We are going to take a look at the 5-5 homework. Remember, we did this one in class when we talked about the square footage of like a room. We looked at the layout of it. And this time we're going to look at the expression and kind of match what the student's thinking was. So one expression for this area is given below. So 12 times 11 minus 4 times 5 minus 2 times 5 meters squared. But where are they getting the 12 and 11 from? Ooh, okay, now I got to think. So this back part is not labeled, but if I add up the lengths across 4, 5, and 2, I'm going to get 11. Okay, so there's my 11, but where's the 12 from? Oh, you know what? I do know area is length times width or length times height, whatever you would like to call it. But I don't have a 12 yet, but I do have a 7 on one side and a 5 on the other side where it meets. Now, if I were to finish it, I would say 7 plus 5 is 12, and I guess that's where I get my 12 meters. The thinking behind this expression is that the person, the student, me, or you, finished this floor layout to make it into a rectangle and then subtracted the little pockets off to the side. So the nice part is that the little pockets, they're rectangles, and we can find those super easy and find the area and subtract it. But we had to kind of think backwards as to, okay, well, they ended with this. Now how can I get there? Now I'm going to use my purple marker to outline the little pockets so maybe you can see it better. There's one, and the other one is on the other side. And that one on the left is 4 by 5. It's 4 across and 5 tall. I can see the measurement on the other side. All the measurements match. Now that one is 2 by 5. It's 2 across and 5 tall. So that's where they get the 4 times 5 and the 2 times 5, those products. So I first started with making that shape a complete full rectangle. Yay, I did that. But then I have to subtract the product from those little bitty pockets, the 4 by 5 and the 2 by 5. That little square that kind of juts out from the bigger part of it, it is a square. Correct. It's a 5 by 5 square. So the lengths or the heights for those two pockets are both the same. But I have to use clues from my other measurements to help me find those missing ones. Again, I started big. I thought smaller. So if I were to write out a different expression, I would say 7 times 11 plus 5 squared. But why do I do that? Well, I do that because I split not the 2, but I split the shape, that given floor plan, into 2 because I used a line segment. As I just showed you, I went straight across. Okay, it looks kind of wonky, but I did go straight across. And I would actually be able to figure out that this would be 77 plus 25 if I were to go through and try and solve it. But when I'm looking at this kind of problem, always start thinking, you are awesome at finding area of all kinds of shapes. How can you find those smaller shapes to add up to make the bigger ones? I think it sometimes can be kind of a confidence issue because it looks kind of scary, but don't let that freak you out. We talked about that a lot in math. Don't let any of these things scare you because I know you can do it. I'm drawing an arrow to point out the line segment. That's what I kind of use as like a bridge to split the rectangle from the square. Alrighty, here we go. There's a net. This is a cube. What's special about a cube is that all the sides are equal. So this says 6 times e squared. That e squared, because it's an e squared, tells me that they found the area for each individual square, but multiplied it by 6. So I found the area for 1, and because it's a cube, I can multiply it by 6, and then I can totally find the answer. So like if each side was 2 centimeters, right? So I'm just going to call it 2. It'd be a 2 times 2, that is 4, times 6, because there are 6 identical squares, and that would give me an answer of 24, if that was the number. I'm just making that up. So the 6 in that 6 times e squared comes from the number of faces. And the e squared, just like I explained, is the area of one face. I know it's a cube, so the numbers are both multiplied together. If I were to write out another expression for this, knowing that each individual square is e squared plus c squared plus e squared plus e squared plus e squared plus e squared. I could write it out like that. But because it is a cube, I don't have to do that. Now, when we're doing this, remember multiplication is repeated addition. So me writing out e squared plus 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 e squared, tongue twister. It's just like saying 6 times e squared. In fact, it's almost kind of easier to think of it that way, so you're not having to make computational errors while adding. And I'm putting a note on here, e squared, because that's the area. I found the area of 1. I'm able to multiply by 6 and get the area for the whole entire net. Now, this actually gives me a number. How much paper would it take to cover a cube with edges 2.5 centimeters long? Okay, so the edges, that's not the area. I find the edges, knowing it's a cube, they're all the same. I multiply 2.5 times 2.5. 5 times 5 is 20. 5 times 5 is 25. Almost said 20. 25, carry the 2. 5 times 2, 10 plus 2, 12. Put down a 0. 2 times 5 is 10. Carry the 1. 2 times 2 is 4. Plus 1 is 5. I add that up. And then I get 6.25 for the area of one of the faces. I multiply that number by 6 because I have 6 faces. So 6.25 times 6 is 37.5. And I would write that as 37.5 centimeters squared as my total area. And I'm going to show you a little ditty picture too. So each side is 2.5. I multiply that together. I then add it all and multiply by